Okay, perfect. I hope everyone can hear me. These are the standard questions in an online meeting. Everyone can see my desktop, and I welcome you all to this workshop or training course on interactive HPC with Jupyter. I'm happy that we are quite some few people who are interested in it, and I personally think that this is definitely the way to do supercomputing. Of course, that's my personal opinion, and I have to say that because we are working on this integration of Jupyter into our infrastructure now for quite some years, and we are seeing more and more people who benefit from these features. And of course, Jupyter itself is already there for quite some years in the community, and is especially in science community a tool which has a large history, and with closer integration into the HPC infrastructure, it is even easier to use and gives you more and yeah, hopefully makes you more productive. So that's the idea behind having Jupyter, or especially JupyterLab, having that introduced in this course. It's a course organized by the Center of Excellence in Combustion, and we are happy that we also could join with the Center of Excellence race, and of course all other Center of Excellence are welcomed, and anyone who has interest in supercomputing and wants to take use of JupyterLab. So my name is Jens-Henrik Göbbert. I'm working at the Jülich Forschungszentrum in the visualization group, and we started making JupyterLab a way to in the beginning started to use JupyterLab to allow easier access to visualization capabilities, and of course it has much more a broader use than that, but now I'm most of the time working in the field of interactive supercomputing. And I also would like to welcome Christian Ritzler, my colleague. He is here. He's also my group. He's actually my office colleague, but last year we could not see each other that often. So hello, Christian, and thanks for also being actively helping all the participants in here in the next 2 days. Christian will manage the chat, because when I'm talking, I'm more focused on what's going on the screen, especially on the JupyterLab tab in my browser. So when you have questions, please use the chat for that. And we are here the whole day. This course will end at 1 o'clock. But if you have questions, we are happy to solve them after 1 o'clock say in a more personal and manner, and so if there are questions who are kind of I would say complicated or cannot be solved that quickly, then I would ask, or Christian will collect them, and we will answer them afterwards. So that's the plan. I know that this course is definitely more easy to follow if you have 2 screens. That's of course not always the case, but you will more or less need 1 screen to see my screen, and then of course you would like to do also your stuff in the Jupyter lab. And so if you have any chance to organize that this way, of course, that's less complicated. But if not, don't be worried. We record these meeting, and you can have a look afterwards, and of course go through all these kind of little exercises, and so hopefully after these 2 days or 2 half days, you're ready and an expert in JupyterLab, knowing, of course, everything. Okay, so that's the introduction. Let's jump in. I already said hello to all of you, and I point out again to this live document. So we try to collect the questions there. Anything which is of relevance for the whole group will be put in this document, and can have a quick look at the document. I suppose you already know it. So this is a document, and any updates will be commented at the top. And at the moment, there's just the general information in here, and some information about the agenda and how to register and log in to the to JC project and so on. So the more interesting questions section will probably then be at the end, or perhaps I can solve everything in one go and you have no questions at all. That's also fine. So just go back to the to our presentation here. So I also said already we have the Zoom chat for interaction, at least for any help which can be solved there. Hopefully, or little questions, please check if that can be solved with Christian. Yeah, then we have the second link is the GitLab. This is the repository where I've put all the notes, all the notebooks and stuff we will go through in this workshop. I can also show you that link. It looks like this. So for now, there's just the first day in there and information about preparing to get ready for this workshop. So here in the README, you see the same information as in the live document. So if you have not joined the training project and or have not even joined registered at UDOR, then I would like to ask you to check the information which are in this folder preparation here, and register to UDOR fz-jülich.de. I even did a nice video how to, so I hope that's clear and easy enough for you to manage this registration. Join the training project, and there's also one video, and then we will let you into this project. This might take some minutes, but there again, thanks to Christian, he will have an eye on that. So if anyone is late, then no problem. We just put you into this training project or compute time project, and when you then accepted to that project, you have to sign the the agreement, a usage agreement, and then your HPC accounts will be created. That can take a few minutes, and after they are ready, you will see in the section Connected Services, you will see this Jupyter JSC button or label, and you can log in to Jupyter JSC. Okay, I jump back to the slides. I think this is at least good to know in the beginning. So while I'm talking, everyone can check if they are ready for that. Okay, so what are we planning to do in the next 2 days? We're planning to have today a JupyterLab introduction. So I definitely want to take all of you at least to some extent to the same page. That might be for the ones who are already familiar with JupyterLab, might be kind of boring, but I hope not actually, because there are always these little tweaks and things to know. And if you have a working environment where you really want to be productive, then it's of high importance, you know, all the little things and tricks of that working environment. So we go through JupyterLab, and we can do that today on our HDF cloud. So it's an OpenStack system where you log in, and tomorrow we will go on a smaller HPC cluster. Actually, everyone just needs one node on that cluster, so we do not have to go on the big systems, even though the JupyterLab is exactly the same on all of our systems. So we take this Yusuf cluster and we'll do there our workshop on that cluster. So let's see what's next. Next is what I already told you. Ensure you are registered at udo.fz-jülich.de. If you're registered, then you should come into a page which kind of looks like this, and there you can join the training project. I really recommend to check the little movies on how to do that, because it took me quite some time to do them. So, but that's not the real case. But at least I'm kind of proud of them. Anyway, you can also just register and log in and join. Here you find a little button, Join Project, just beneath the section Projects, and you click on there, type on Training 2109, and wait until we let you in. And you can sign the usage agreement, and you will find this little button down here, which will tell you then Jupyter -JSC. So you should see if everything is fine. Just check in your Udo. I just emphasize on that because it's kind of sometimes an issue in the workshops. You have to see this green label under the system's UDAC and also under the system Yusuf. So if it's yellow, then you have not signed the usage agreement yet. So please make sure that under the systems you have this green label, and it tells you that the usage agreement has been confirmed. If you just click on sign and you sign, then you will see that this yellow will not go away right away. It will more like showing you there's something in progress. And these are these 10 minutes until your HPC accounts are created on the systems and everything is communicated and so on. So just wait if you see that this yellow box or yellow label is telling you, yes, we are just in progress of creating the HPC counts. Okay, so I hope everyone just sees the sections with these green checks and is ready to go. Then I jump into the motivation, and I always show this sentence because I like it. This sentence just tells what's the idea behind Jupyter or behind JupyterLab, and yeah, you're just reading it. It's all about building a machinery interface between computational researchers and data, supercomputers, laptops, cloud, and and that's the important thing, your thinking, your reasoning, your insights, your ideas about a problem. I think that we often tend to adapt to or have to adapt our workflows actually to the machine instead of the opposite, that the machine adapts its workflows or its kind of thinking to our thinking. And I believe that JupyterLab is a step towards making a supercomputer behave more, or at least accessible more like we humans think. And that's I think a good starting point. Even though, of course, it does not mean that a terminal is now not needed anymore, and definitely JupyterLab is not something like it does not replace the terminal, but it can help to make a few things more productive. So this is an old slide, but I'm sure it will still show the same behavior. Here you can see how popular actually Jupyter Notebooks became, starting with 2015 when you look at GitHub and comparing it to R and MATLAB, for example, just checking how many active repositories have been there, and this really shows how popular and how worth it is to having a look at these Jupyter Notebooks. You see, I'm really starting at the basic level, but I think that's important to get the whole story. So just starting with the terminology, what is JupyterLab? JupyterLab is, first of all, it's an interactive working environment in the web browser for creation of reproducible computer-aided narratives. So you can write your science like a story. You have sections where you can write text. You can have sections where you can program, have your output plots, rich media, video, and so on. And all these can be done with all different kind of languages. So Jupyter is not kind of focused on one language, even though probably one would say Python is the main language one would use in JupyterLab. But there are roughly 50 different kernels, and I'm already now at the second important word, which support different languages. The name Jupyter comes from Julia Python R. These were the first languages supported, and I already said it's language agnostic and has a client server. No, that's not what I want to say here. It can be extended through a lot of extensions, and even you can even have a terminal like you see here, terminal in JupyterLab and file browsing in JupyterLab. So you can enter this environment in your browser, and you can use it just as a terminal. If you like to stick with a terminal, that's fine, but then you have a terminal in your browser, can be of benefit. But of course, there's more. So it allows all the kind of standard ways to access a system, but adds more on top of that. Actually, you already see I'm even in JupyterLab right now, showing you the slides. Of course, that's for a workshop like this. How could I do anything else than this? So let's talk about the second word. So that's the general, talking generally about JupyterLab. So JupyterLab can show, or the documents where you are working with is the Jupyter Notebook. So Jupyter Notebook is, in the end, a Jupyter Notebook is a file with the extension IPyNB. And this file can be rendered and therefore shown in JupyterLab. And the file itself is a JSON format, so you can open it in an editor and you see, kind of human readable. And because that's a standard for quite some years now, so this was already there, Jupyter Notebooks before JupyterLab. It came with Jupyter itself, or with IPython, and so actually that's why it's called IPyNB, so IPython Notebook. So it's a standard, an open standard for interactive computing, and because it has been there already for quite some years, there are a lot of different tools who can render these files. It's not only that you can render them in Jupyter or JupyterLab, you can render them if you put it on GitHub and you open that file, you see it rendered and not in this JSON text, you would see the rendered file. You can convert these IPyNB to all different kind of formats. So here you see, if you're coming from Jupyter, you have your IPyNB file stored on disk. You can make PDFs from it, HTML. You can put it on GitHub, or you can even write your next paper with it and render it. So it's the file which will have your kind of story, your science in one place. It also allows you easily to share your workflows. You can send these files to your colleague, and everyone has already all the documentation, can run the code and can reproduce what you have found. So it really speeds up science. So and then there are these Jupyter kernels. Jupyter kernels are the separate processes which execute any program you have written in your Jupyter Notebook. So the Jupyter Notebook is separated in cells, and you have cells which are actually code cells. And when you run these code cells, you need a process which is executing that. And the Jupyter kernels are the ones who are executing your code. So they are separate from your graphical user interface. They normally run on the same machine, but they do not have to run on the same machine, which is a big benefit for us in supercomputing. And the JupyterLab user interface, or the JupyterLab notebook server, that communicates through 0MQ with these kernel. And there are multiple pre-installed Jupyter kernels, at least on our setup. We have Python, R, Julia, Bash, C++, Ruby, JavaScript, I don't know, probably I forgot some, and specialized kernels for the visualization, quantum computing, deep learning, and so on. On the HDF cloud, they are currently a few less, but you are free to create your own kernels, and probably also, not probably, but most of the times that's also something you want to do, create your own kernel, because you have a special Python environment, you have a special whatever environment with special software and so on. So you want your code cells to run in your personal kernel, and we will check that tomorrow. These kernels give you a high degree of freedom in what you want to do, and making this whole environment, this whole JupyterLab environment, so flexible and adaptable to different scenarios. So yeah, coming from Jupyter kernels to JupyterLab extensions. Also one key word in this JupyterLab universe, JupyterLab extensions. Actually, JupyterLab itself is it's a bunch of extensions. Even the core features of JupyterLab are in the same way extensions as third-party extensions are. So you can extend the features of JupyterLab, or a lot of people are extending these features of JupyterLab. You find a lot of different file viewers, editors, themes, of course, and also ways to do output to your in your notebook. It can extend the menu, the command palette. You have can extend shortcuts and so on. It can add. You can even rearrange the whole JupyterLab if you would like to that extent that you cannot see anymore. It was JupyterLab at all. But the most important thing is that special research communities come with their special extensions, and that makes this environment even more productive. Yeah, this is more advanced, writing JupyterLab extensions, but if you are in a bigger community, then you will find these extensions, or you will find people who are interested in making these kind of extensions. So another reason why JupyterLab is so flexible and can adapt to the different scenarios it is used to are these extensions. So how would a standard use case look like, looking at all these different bringing everything together? So you will see yourself here at the left, and of course you're sitting in front of a computer and you have opened a browser. So in the first step, in the classical situation, if you are connecting to an external site, so I'm here already focusing on using JupyterLab, not on your local PC, but using it for an HPC scenario. So in the classical way, you would SSH to a terminal, to the login node, or wherever you log in SSH to, and you would there start your JupyterLab. JupyterLab is a Python program. You would somehow load perhaps a module on the system, or you have installed it in your home directory, or wherever you find JupyterLab. We have installed it as a module. One can load it, and every kernel is a module. You can load a collection, but I come to that later. But you would load your JupyterLab and you would start that JupyterLab. And starting the JupyterLab in this scenario would just mean that on a special port on this login node, JupyterLab will listen and will provide its user interface. And to make that accessible from your local browser, you would need an SSH tunnel to tunnel that special port. JupyterLab would tell you, I'm running on localhost 8888, which would be the classical port. And then you would tunnel that to your local PC, and you would open in your web browser localhost, whatever you perhaps you have tunneled it also to 8888. You would open in your browser localhost 8888. You would have access to the user interface, seeing it in the browser, like we see it now here in my browser. And this JupyterLab then has, as I said, all these extensions. These extensions can work on the server side. They can run on the client side. Here on the client side, of course, everything is JavaScript, but you do not have to bother. That's somewhere in the background. And on the server side, it's in general Python. And then you have your Jupyter Notebook server running. And when you open now an IPyNB file, you would load that IPyNB file into this Jupyter Notebook server. It will be rendered, shown through the tunnel shown in your browser. And when you start any code on this Jupyter in this notebook file, in this Jupyter Notebook in kind of command cell, then you will start a Jupyter kernel as a separate process in general or by default on the same machine, and you will then run your code there. That's kind of nice, but still means that you have to do an SSH to the terminal and do an SSH tunnel. And so you're actually trying to use some kind of new feature of doing supercomputing in your browser. But first of all, you need to SSH to a terminal. So that's not 100% doing supercomputing in the browser. So we decided to use to put in between some extras to avoid this SSH requirement and to give you really an experience with this 100% supercomputing in the browser. It just means that in the center of, instead of doing it manually, this tunneling, now Jupyter Hub and two extra services and a little bit glue in between will ensure that whenever you want to start a JupyterLab, you just have to go on https jupyter-jsc.fz-jülich.de and then log in there and open your start a JupyterLab. So let's have a look at these pink box in the center. You might have already logged in, knowing how it looks like. This is the front page. Here you can log in, and then you will start your JupyterLab and seeing this kind of progress until running until 100%, and then your JupyterLab should come up. To allow this, we had to add two special things. I just want to mention them. Unicore is our service on the HPC systems, which can start or which is trusted to start a process in the name of a user. So of course you do not want to have something like an untrusted part of these services should not be or must not be allowed to start anything in your name. And therefore Unicore has already quite some history and is doing that job. And Jupyter, or actually Jupyter Hub here, has to ask Unicore to say there's a user I would like to start a JupyterLab for that user. And the critical part, of course, is the identity management system, where you log in and where you actually, which ensures that no one else is starting services than the one who is allowed to do that. And so also in this pink box, there's this Unity IDM, which is our authentication service. And when you log in, you receive the token, and Unicore will ask Unity IDM if that is a valid request. So this system had to be set up, of course, that it's requires the security we need for a supercomputer. Okay, so here we are typing in jupyter.jc.fz-jülich.de, and when you are the first time logging in, then you will be seeing a dialog here, number 3, seeing a dialog showing you this register button. Clicking on that will ask you to confirm the terms of use, and if you have done so, giving here this check and saying submit, we will receive an email, a confirmation email with a link, which actually brings you back to the JupyterLab Jupyter JC login page, and you're ready to use it. Okay, so just going back, so here, yeah, I would like to ask you to log into our Jupyter JC now, and I would like to give you some or point you to some information there, and then I keep on talking. Just let me open a private window to see the login page again. So you should, when you enter your Jupyter JC, you should see something like this. In the bottom, you see that our systems are, at the moment, no system is in maintenance. All systems are available. So we will go here on the HDF cloud today, and tomorrow we will go on Yusuf. So let me click on login. And here I have a second factor activated to my login. So just let me type in that. That's an optional for now, but I'm sure we will see that in future more and more. And so one can already get used to it, but I come to that later. So you will see how I have zoomed my page a bit. You see it's 150%. So this kind of looking a little bit squeezed, but I think this way you have can better see what I mean. I would like to point you to this group up here. So up here you have the default group, and I've added a Center of Excellence minus Jupyter group. And to ensure you are directly at the same spot, there are quite some options on the way. I would like to ask you to choose this group, Center of Excellence, Jupyter, and then you can give here in this box, you can give your JupyterLab a name, and say new JupyterLab. And then we choose the HDF cloud. And there we have just one image to start. So the HDF cloud is, as I said, an OpenStack cluster. So that means we have a lot of virtual machines running there. On the virtual machines, when you start your Jupyter, the container will be come up, and this container will have here the image. Will use the image Jupyter JC 2020 2.6. The 2020 comes from our software stage, which was released in November, and therefore it's still 2020. And 2 is for JupyterLab 2. We have already a JupyterLab 3, but for this course I would like to use JupyterLab 2 because JupyterLab 3 is has not all extensions already ported. So we'll stick to JupyterLab 2, and the 6 is our internal version of this JupyterLab installation. So you would choose this image. Actually, there's nothing else to choose. So that makes it easy if you go on this group saying Center of Excellence Jupyter, and then you start it. Please start it on the HDF cloud for today, because we really do not need HPC cluster in the next hours when I walk through the interface and showing you all these kind of little tricks and hints. Okay, so just go on with that, and I will go on with my presentation, doing a little bit of advertisement while you are logging in. So Jülich, Forschungszentrum Jülich, as I said, I haven't been there for quite some time because of the Corona situation in the moment, but I'm sure it still looks the same from above, and it's in the middle of the forest. And so you see quite some green and trees on the campus. But the most important, at least from my point of view, the most important is just here on the right. This is the JSC, the Jülich Supercomputing Center, and there our machines are standing just in this hall and are working for us. So they just need some work to do, and we're happy to give them work. And so just see how this Jülich Supercomputing Center is organized, or what does it operate? It operates, of course, supercomputers for the center itself, for the Jülich, for the Forschungszentrum Jülich, for the region, which means especially the Aachen University, which is close by, just 35 kilometers. And it's organized also in the Gauss Center for Supercomputing, which are the 3 big sites in Germany, Munich, Stuttgart, and Jülich. And they provide compute time for Europe and, of course, for European projects. And that's why we, as a Center of Excellence in Combustion and Center of Excellence Race, are here on these machines doing our research. Of course, operating an HPC center or HPC clusters means you need quite some application support, porting them, making them run as efficient as possible on the quite expensive machines, and doing peer reviews of and support and coordination. So there's a lot to do just behind the scenes, at least from the view of a scientist. And but not only that, there's research and development work going on. Methods, algorithms, computational science, performance analysis on tools. And that's also why we're happy to be part of the Center of Excellence in Combustion here. And also computer architectures, co-design, exascale laboratories, and a lot of educational training. And that's what we are doing today. Just having a look at the kind of history of the JSC from the point of view of the supercomputers. So there are two, there has been two machines for in operation, two big machines in operation for quite some time now. Always one which is highly scalable machine, and one which is a more general purpose machine. Now we are getting them more and more closer together in the idea of modular supercomputing, but this probably is would be a talk on itself. So just knowing that the current machine is the Joules Booster here, and the Eureka DC module, which actually is in production already. So this slide is kind of old, so I better go on for the next one. And nowadays, it's not only about supercomputing, but a lot about storage. So there are hundreds of petabytes stored in the machine hall, and accessing them always is a conflict between cheap and fast and highly expensive. Cheap and slow and highly expensive and fast. So the large storage system, the archive, and then getting faster and faster until a bandwidth optimized capacity limited storage, so which really gives you high speed, especially for machine learning. This is of interest when you crawling through a lot of data and you're just jumping and reading parts of that. So there's all in between, but this is not, again, not a topic of us. I just would like to mention that these systems, at least most of these systems, they are accessible also on the HDF cloud. They are currently accessible through read only by standard, but can also write on them through the HDF cloud. So when you think of JupyterLab and you just need to do kind of little things in compared with things which are possible on supercomputers, then you might want to go on the HDF cloud, tuning a bit, and you have your data available there. This is not the case for archive, and I also don't think it's the case for the top one, because this is actually not a file system itself, but more a layer on top of some other file systems. So just jump to the next slide. You just keep in mind, wherever I'm on the systems, I don't have to be worried I have no access to my data. That's what I wanted to say here. So there's a lot of domain-specific support, little groups specialized in different topics, simulation and data laboratories, and are more research topic focused, or teams which help and develop and do research on things like visualization, parallel performance, mathematical methods, and application optimization. Okay, that's enough for advertisement, and and I hope you're logged in, and you have a similar view than I do have. I can, you see that this, I'm currently in a JupyterLab running on the HDF cloud. If you zoom in, you could see that this is in my URL visible. And I can, I'm now in a single document view. Just let me go to the kind of standard view. So standard view would probably look like this. First thing to do is I would like to ask you to clone the repository where all the material for today's workshop is in. And of course, you can go in the terminal and clone it there, but as we would like to do everything with JupyterLab, we are going here on the sidebar, and you find this Git extension there. I'm already in the directory, so let me jump to a view which is more the view you have. You probably ended up in a view where you see this just homes read only, so just in your home directory. And if you are there, you can you can click on this Git extension, and there you find this clone repository button. So when you click on clone repository, we just type in the repository. So you find the repository in the live document. I just scroll up in the live document. Here, workshop materials. There's the link to the repository, or I've already opened that repository. And this is on our GitLab. So you see this clone button, and you just copy this HTTPS address. And go back to JupyterLab, and you would put it in here. I've already cloned it, so I do that again. I just see that someone is missing the link to the live document, so let me pass it in the chat. Okay, so if you have cloned that repository, then you see I've last modified it 21 hours ago, so you should have this directory: Center of Excellence 2021.5 Jupyter for HPC. Just go in there and go on day 1, and have already went through the presentation, which I put in the directory welcome plus login. So we can now go to the tour, doing a tour. So when you go in the tour user interface, you find this Jupyter Notebook. Yeah, it's actually for myself to remember all these little things, because if one has no reminder, one is often too quick and forgets about this one or the other thing. So it's a reminder for me, and perhaps for you afterwards also, if you go through this and remember all these little things. So yeah, JupyterLab tour. So if you're interested to have nice Jupyter notebooks, then I really would like to point you to this gallery of interesting Jupyter notebooks. It just is what the name is. It's a gallery of interesting Jupyter notebooks. And it really makes sense to go through them, having a look at them. I learned a lot just by looking at others' Jupyter notebooks. So this just giving you this link here. Of course, there are really millions of Jupyter notebooks, so I'm sure you will not have a problem of getting any interesting one. If you jump from a terminal to a complete new interface where you really want to work with and do not just want to click around and then go back to the terminal, then you should know what the idea or what the structure or how it is built up and to understand what's possible there. So JupyterLab provides flexible building blocks of interactive exploratory computing. So you have the Jupyter notebooks. We are just in one of them. You have the console. I have opened up here one. So this is a standard console, like you would find every what else can I say? It's a console. So or it's a terminal. I'm confusing you. No, it's a terminal. And you have a console. The console is actually something we will see in a minute. And you have editors. So everything of this is happening here in this workplace. As you would expect, you can make it bigger and smaller, and I think this is really something which is kind of nice. You can organize your tabs however you like to organize them. If you move them to a center, then they will be here stacked. If you go to just to the side, you see, if you go to the side, this side, or you go to the top side here, then they will be up there, and you go to the bottom side. That's so I don't know anything what you cannot do to organize them. If you're that of course makes only sense if you have really a bigger screen, not here on my laptop, but this just can get me this a little bit in order again. So yeah, that's how you can organize your tabs. And you have these sidebar here, the left sidebar in JupyterLab 3, you can right sidebar, but anyway, here you have this left sidebar. You can collapse them, or you have the same button for up here and the view to collapse them, and therefore the menu at the top, and of course the status bar at the bottom, and up here the system tray. So just go through a few things. I rotated the sidebar screenshot a bit, so first of all, when you start JupyterLab, you will end up seeing the launcher. Here as I've already opened stuff, and I don't see the launcher anymore, but I can start it just by going to the file browser and clicking on plus. So here you see this plus sign. When I click on plus, I come to the launcher, and the launcher will show you the different Jupyter notebooks you can start, or actually the different Jupyter kernels which are available here on Jupyter, on Jupyter JC at the HDF cloud. We just have the Python kernel, the Bash kernel, JavaScript, Julia, Octave, some special kernel for the deep learning community, and a Ruby kernel. Then you have the console. The consoles are, in contrast to Jupyter notebooks, they are like an IPython. You you type in and you get a new column, a new row, and you type in again and type in again. So it's not a document where you jump between the different cells or can go up and execute something at the top and then execute something at the bottom, but the console just goes one after the other. It's nice for debugging and yeah, some other tricks. I'm coming to that also later. Then the terminal, I already showed you the terminal, standard terminal, and editors for text files, markdown files, and especially for help when you do programming. So going back to the sidebar, basic operations, of course, you can imagine that we have copy, paste, delete, rename, and so on. And when you hover over it, you get the kind of details about your files. Perhaps something what is kind of surprising but important to know is that you cannot see here in the file browser hidden files. That's really a pity, I have to admit. Then for hidden files, I have to go to the terminal, and oh, I have no hidden. Yeah, I have some hidden files here. So you see, you cannot see the hidden files in the file browser. You can do drag and drop. So like if I want to copy something, let me copy something from here. What could I copy? Come on, I copy this nice logo. Then you can see I can copy it there and will be uploaded. So that's kind of nice, and we can also drag files. Like here, I go to the data, I have some markdown Python file, and drag it in here, and so it can be loaded. Okay, that's nice to know. Upload, download. Here we have the upload button. Upload a file. Then I can start uploading anything from my local machine and download. You can click here on download the files. We also added these extension favorites. Sometimes one is into a special subdirectory and do not want to always go to this special subdirectory. You have to see the star up here. You can click on the star and you will see that you have now these favorite set to this subdirectory. So when I go to my home, I can jump to that subdirectory just by clicking there. So having kind of favorites, I think that's really handy. And if you are in a directory where you can do a git clone, then you see this button up here for git. So here now it's enabled. So here I could also do git clone. That's the same as if I would go on git and do clone repository through that button here. So let's go back here. Perhaps it might be strange, but when you find this copy shareable link, that does not mean that you can copy that link and send it to someone else and share that link, because if someone has that link, then of course this person will end up at the Unity IDM and Unicore level and needs to authenticate himself, and so this link is not really shareable. And only you yourself can share that link to yourself. Okay, so going down here, coming to the running panel, this is also important to know. Whatever JupyterLab whatever Jupyter Notebook you see, or terminal, or console is running, you do not need to have a kernel running just in the same moment as you see your Jupyter Notebook. So here we have this Python kernel running, Python 3. Here you see we have Python 3 kernel running for this Jupyter Notebook. And this is exactly showing here in the running terminal and kernels panel. You see we have these running session. But we can close our Jupyter Notebook and you see that the kernel is still running. So when you start your Jupyter Notebook and you just close it, that does not mean that your kernel will stop. You can even open that Jupyter Notebook again, and your kernel is still running and has still the same variables and is the same status. So this is important to know, because you are limited on the HDF cloud by 2 GB of memory in maximum. That's of course not that much, but for an OpenStack cluster in a container where you just want to do some kind of little plotting and setup, that should be fine. On the Jupyter, on the HPC clusters, of course, you have more resources available. But therefore, this memory up here will show you the memory consumed by all your running kernels. And if you just close your Jupyter Notebooks, but do not shut down the kernels, then your memory will not drop. So ensure that you know which kernels you have running, and that you shut them down if you don't need them. Yeah, or you can even say I'm closing my Jupyter Notebook for now, concentrating on just one certain special notebook, and then I still have it running in the background. So that's kind of important to know, that the Jupyter Notebook and the kernel are two different things, and you manage your kernels, your running kernels here, and you have your Jupyter Notebooks opened here. So if I would go now here on say I would have no kernel at all, then I can see that this kernel is closed. Okay, I don't know if we need a Python 3 kernel, which is that one again. I told you that Jupyter is a collection of extensions, and all these extensions have in common that they add commands and make them available to the JupyterLab ecosystem, and these commands are not all visible in the through the menu or to any buttons. So it can be that there are commands which you don't know of because you have never seen them, and there is this commands panel where you can find really all commands which are available, and you can see some of them have key shortcuts, some of them do not have shortcuts. So there's quite some commands available here. Launch new. This is here. You see, this is from the extension Dask. This is from the extension Help and a launcher. So everything what you can do by clicking on any kind of buttons, you find a command in here, and even beyond that. So this is also good to know. Yeah, I just showed that there's a shortcut, Control Shift C to open this command. Some Jupyter Labs really made to be 100% used from the keyboard. So if you like to do not touch the mouse at all, I'm sure that's possible. Property inspector is the next one. Property inspectors, you have your Jupyter notebooks. They have meta information which you do not see when in your here rendered notebook, and so sometimes it's nice to know what meta information are in here. Here you can see that the Python language and the name of the kernel is saved in your Jupyter notebook. So if you have a special kernel like my superkernel and you give that Jupyter notebook to your colleague and he has no superkernel installed on his system, then he will open up this Jupyter notebook and will not see any kernel loaded and needs to then decide for any other kernel to load. So the information which kernel belongs to this notebook is saved in the Jupyter notebook file. So there, and open tabs. If you are in the single view mode, sometimes if you do not have enough space or for whatever else reason, then you can switch between your tabs in here. Okay, that's not what I wanted to do. So file formats, they are just, let's go in these data directory, and there are all different kind of example files which show that JupyterLab has different readers for files. Starting with HTML, here you see it's not rendered right in the beginning. You have to say you trust this HTML file, and then the HTML file is rendered. IPy notebooks, we already had that. Logo, not logo, any image with minus, I can make it smaller. Here now it's nice to know that some shortcuts are grabbed by your browser, like I should be able to make it larger with the equal sign. So if I go on commands and zoom in, you would see its equal sign, but it does not work. So that's the reason, because your browser grabs some of the keys and does not pass them to JupyterLab. Just keep that in mind. If some shortcuts do not work, then one has to think what is the browser actually doing while stopping me. We have SVG, Markdown, and all different kinds. I think the CSV also is nice. If a viewer directly for CSV files delimiter can be changed at the top. A JSON viewer is in here. So I told you that the Jupyter Notebook files is a JSON file. So if you right click on the IPyNB, you can go on Open With, and then you can, instead of using the standard viewer, you can use, for example, the JSON editor or viewer. And now you see this Jupyter Notebook file in JSON format. You can here, for example, see this meta information. We also got, when you go on properties, property inspector, but then we have to open this. We see the property inspector. So, I just want to ensure you know there's not just Jupyter Notebook IPyNB files. There are extra file formats, and you can have, of course, more file formats if you add extensions which are able to read them. So these are just the standard ones. I just close all these files again, clean up a bit. Okay. So where are we? Yeah, I would like to mention Markdown. The standard Markdown file is the one with edit view. You can go on the Markdown file, right click and say open with preview, Markdown preview. I close the file browser again here, and then you can see I can put it side by side and have live editing. So saying like so if you work on Markdown document, then this is kind of a nice feature, having this side by side. You can even say I attach a console to this Markdown file. So when I click here on the Markdown file at the top and go on New Console for Editor, then the console opens, and I can choose which kernel I want to use. Say, okay, I want to use a Python 3 kernel for this console, and let's put that console here. And then I can select code and type Shift and Enter, and then have this code in the console and can run it there. So yeah, you are able to attach kernels not only to Jupyter notebooks. That's what I wanted to tell you. Or you can connect them even to Markdown files. And okay, so close this one again. This too. And now have a look at the running terminals and kernels, and we see that now kernel session here is for Markdown Python MD file. So this kernel is still running, even though I've closed the files. And we also see now we are 290 megabytes. So when I shut down the kernel for this Markdown Python MD, it drops down to 175. So yeah, that's said. We went through all these files. Just a few words to the menu. Here I would like to point you to these to the checkpoint file. The checkpoint file is a file with the file ending dot IPy checkpoint, and it is created or it is updated whenever you manually save your Jupyter notebook, not when it's automatically saved. So when you do any change in your Jupyter notebook, let me do some of the change here. Then you see that it is not saved. Up here you see this filled circle, and in autosave is set to 120 seconds. So every 120 seconds, your file is automatically saved. But not the checkpoint file. So when you update your, when you manually save your file with this button or with Control S, then your checkpoint file is saved. So just to have that in mind, if you autosave, if you destroyed something, then you always have your checkpoint file. Okay. Edit. What else? Want to focus on. We have this show log console. That's perhaps also some additional information, especially when you're using widgets, IPy widgets. There are sometimes messages which you cannot see in your Jupyter Notebook. Then they are passed to this console. Yeah, run, just anything on run, we come to that later. Kernel, here you see that extensions can add special menu entries. Here it's the Git extension which adds special menu entries. In the tab view, you can see the different tabs, especially then when you perhaps say, I want to go on single document view. Yeah, you can switch between the tabs here, or you can switch between the tabs here. That's just what's less, what's easier to use. Settings, here just like to show you, yeah, you have some people like the dark theme, so that's kind of nice. But anyway, I go back to the light one. And on the settings page, the most important, I would say, is the advanced settings editor. So in the advanced settings editor, we can see all the settings of JupyterLab. They are system settings, and you can always override them with your user settings. And think of it as one big JSON file, and your user preferences are put underneath. So you have to write your user preferences as a JSON in the JSON format. You can, if you want to change something, you can just, for example, copy the system defaults and then pass them in here and change whatever you like to change. You will see that it can only be saved when there are no errors. So if I have some syntax error like true without an E, I cannot save it. And whenever you save your user preferences, then just in that moment, they will become active. So I just remove that again. These are, okay, coming to the settings. And yeah, and perhaps in help, that's also nice to know you're still able to launch the classical notebook. We launched the classical notebook. We are running this on, this is just a different view on the currently running Jupyter Notebook server. So there's not in parallel running a second Jupyter environment, but it's the same one, just with a different view. So keep in mind, it is not wise to start to open the same Jupyter Notebook in the classical and in JupyterLab at the same time. But to be honest, I don't really know why one would like to use the old Jupyter, and it's kind of passing away. Few words to the status bar. You see down here how many terminals are running. One terminal is running. And here in the, currently we have one kernel running. This is the same as if you would go on the panel view here. We will also see we have one kernel running, one terminal running. We have additional information about the extension Git. It's idling, nothing special. Then we have this language server running here. It is fully initialized. That means it's ready to serve with information. This language server is for additional help on your programming code. So come to that later. It shows you what is the current kernel. and if it has any work to do, memory is the same as above. This information is kind of important when you edit. You can be in a command on the edit mode, see that later, and then we have this information on trusted notebooks. So because your Jupyter notebooks generate output, and this output can be JavaScript, and JavaScript can be kind of dangerous to execute in your browser. Therefore, Jupyter will analyze your cell and will not show things where it thinks these are kind of dangerous JavaScript code. But beside that, it will tell you if it trusts a notebook or not, or especially which cells it trusts. If you have executed certain cells and the output of these cells is generated in your by yourself, then this cell is trusted. If not, then it will show you this notebook is not trusted because someone else was generating the output. So Jupyter notebooks cannot only have the text and your commands, but as you know, also output. And this output is then this is analyzed. So most of the times, probably you will see that the notebook is not trusted because output comes from someone else, and you trust this other person, or you trust JupyterLab that this output is of no danger. Yeah, of course, where we are currently, go to line number. Here we have a spell checker, which is set to English American, and the file name. So yeah, okay, so just a few words on the memory. As I said already, 2 GB. Whenever you reach 2 GB on the HDF cloud, the kernel which is running, it stopped. So the container tries to be kind of nice and just kicks out the kernel, which is taking most of the memory. So you should be safe that your JupyterLab is not the one which your JupyterLab's notebook server is not the one which is killed. But when you reach the 2 GB, then there's, as you know from OOM killer on Linux, it's kind of the same here, needs to be cleaned. If you're of course on a HPC machine on your node, then you can fill up the whole memory as you like. Okay, so yeah, the tour is done. And I have to drink something. And would give you the time to play around, or we just go on with some more details. Probably it's the best I just keep on. And as I said, we are here to stay after 1 o'clock, and I would like you to collect your questions and so on for that, or in the break. And I really have to hurry to get all this information to you in just 2.5 days. So I just go on with that. So we go to the first steps. So I'm now here in day 1, folder 3, first steps, and I will get rid of a few of these tabs. Tabs also here, like to clean. And go back to first. close the file browser. I'm clicking on clicking on this file browser button. Yeah, just some words on coding. I already told you you have these modes, command and enter and edit. So when we hit enter, we get into a cell, and we can edit that cell. If we hit escape, we get out of this cell. Then you're in command mode. You already see that this does not mean that the cell actually is rendered, it just, or it's executed. Here we are seeing markdown, a cell which has is of type markdown. When we hit control, enter, this cell is actually executed. And as we are in a markdown cell, you see it up here, markdown. We have code cells, markdown cells, raw cells. So markdown and code is probably the one we use most of the time. Then we have these, executing this cell means, oh, sorry, now I'm in raw mode to go. Means running that. So as I said, you can press Control Enter, and then you will see here always a different random number. We will stick to that cell and we will execute that cell one after the other. If you want to run it and go to the next cell, we can say Shift Enter, and you can see here the active one is blue. Again, Shift Enter, and I can say Alt alternative Enter, and I would execute it and create a new one. So these are just the standards. So important here also is help. How can I get help? If we, for example, want to get help about pandas, as I said, we have this language server running here. It analyzes what is loaded. So we have pandas running here, and we can say we want to get just the information where the file is and so on. Extra information that's that can be done with just entering pandas. But we have a question mark, then we get these extras about the module. I think for myself, this is always important because we have so many places where different kind of versions are installed, and sometimes one gets confused what is actually loaded right in the moment. So I often just check what's the path. So the standard question mark. We can, if it's this too long, you click on the blue blue bar, and it's collapsed. If you go with 2 question marks, you get even more information, even the code itself. So this can be very, very long, and therefore you can decide if you want to have enabled scrolling for output or disabled scrolling for output. So standard is disabled scrolling for output, and then you would see so many output you really probably do not want. So one can just say enable scrolling for output, and then you would have it scrolled here. This is, for example, one good example to show what meta information can be in a cell. So here the cell as the meta information scrolled is true. Okay, so if we want to have Oh, my language server is not running. That's strange. Okay, I cannot show you the language server. So normally I would expect having pandas and going on tab to see more information, or getting a dot and then getting auto completion there. It's strange. This is not running now. I can try to shut down this kernel and then start again. Okay, so I cannot tell you why this is currently not running.
I think you're missing the import, therefore it doesn't know pandas yet, because it didn't execute the import pandas.
Ah, good point. Good point. Okay, I have to check that, but not now. So this actually, the language server is quite a nice feature here. You can have extra help always on the side. Just open here the launcher, then you see the show contextual help, and we can put that aside, and then we always have this help on the side. Here you see when I always try it again. Okay, so the contextual help is then quite of nice. Just close that again. And display output. So here we have special renderers for the output, like this pandas renderer, or of course the matplotlib, which is one of the kind of standard ways to display output. The output can also be in a separate view. You can go on the right click on the output and say then we want to create new view for output, and have here on our output always nice at the side. If we go on with our work, we can always see the output there. And if you rerun it, so this is linked. So if we rerun it, you can see, as it's the random dots, you can that's not really random. Okay, sorry, I'm grabbing the data from here. So you can see that these plots are linked. I already showed you collapse output. I showed you output cells, and yeah, we have a formatter here and there. Go and say format cells. Okay, that's already quite format, but here I think the formatter would change the ticks. And so there are formatter in here, which also makes life a little bit easier. If you want to change the formatter again, settings, advanced settings is your help. There you can choose the JupyterLab formatter, and you can change things here. Just Google how to change the formatter if you want to have it just close by. Okay, so we have seen the formatter here, and we can run, close the output view, it's kind of not useful anymore. We can run shell commands with an exclamation mark and even JavaScript. Here you see a dialog pops up. That's actually one of the reasons why this extra trusted notebook information is shown, because you can really run JavaScript from there. Yeah, I walked through these trusted notebook information on here. I think this is also quite nice. You can open a new view for the notebook. No, sorry, yeah. And now we can, if we have the same notebook side by side, we can copy cells in the same notebook to other positions. Okay, the JavaScript cell is perhaps not the good one. At least the output cell is not a good one to copy, or we see always the dialog. And now we have this cell copied to the top. So you can see here it's copied to the top. So this is also nice and helpful. To one kernel, we can have a Jupyter Notebook attached, but we can also attach a console at the same time. So we can click here on the top and go on new console for notebook. And then we would have a console running, which is connected to the same kernel. And therefore, we can execute in here something like b is equal 10. With Shift Enter, we can execute that, and we could see that this 10 is now also shown in the notebook. So just keep in mind, we have one kernel running. You can connect a console, a notebook. You can connect multiple notebooks to the same kernel. If we, for example, create a new notebook like this, and then we choose here, we choose the kernel of the other notebook, of the JupyterLab coding notebook. Then we also have this B listed in here. So the kernel is the Jupyter Notebook can only connect to a single kernel, but a kernel can be multiple kernels, multiple Jupyter Notebooks, multiple consoles, and so on, can connect at the same time to one kernel. Okay, just put that up here. Yeah, just to show you, more on these I think very important thing about these consoles. When you, for example, have a Jupyter Notebook and you do debugging, of course you can always create a new cell, a new cell, a new cell, and mess up in your nice Jupyter Notebook, or you just connect a console to that notebook and play with that console, or you can connect a second notebook and do all your work and ugly hacking in that second notebook, and have still the prepare the whole kernel with the first clean and nice notebook, and then do stuff on that prepared kernel, then in the second notebook or in a console. So here we also another proof, but I'm sure you believe me, another proof that we have this one kernel connected from the notebook and the console. Yeah, we can even say we want to plot something in the console. So therefore we just click on this cell and we can drag it down here and Shift Enter, and we would do also our plotting in that console. So nice for debugging. Let's see. Yes, I've shown you that, dragging, syncing. In general, if you connect the console to a kernel, it only shows what happened, was executed from in the console itself. If you really want to follow every step the kernel is doing, even if the command comes from a Jupyter Notebook and not from the console itself, you can right-click and say show all kernel activities. And then you will see that any activity I'm doing now in my Jupyter Notebook, like this one, is shown in the console. So this number in front, sometimes we see a jump in the number if we do not tell the console to show every command. But if you want to see everything, you just say show all kernel activities. Okay, I think we are done with these standard coding informations. And I go back to our overview. Yeah, then we go on with Markdown. So you can find all different kind of Markdown tips and tricks for, of course, not all of them, just the ones which I think are very important to know. I suppose you all know what Markdown itself is, and there here in JupyterLab, most of the Markdown techniques are available, like the ones for italic and bold, and like quotes, codes. Just go through these to see how that is done. Here, I think these checkboxes are nice. Tables are done like this. MathJax is the one which is rendering any kind of equations. It's a subset of text and LaTeX, so should be able to have most of the equations being rendered in Jupyter Notebooks. I'm sure there are some which are not able to be rendered. I have not seen one yet. Graphics, there's one important thing to know. Graphics can be drag and dropped into the Jupyter Notebook, and then they are integrated in the Jupyter Notebook. So so you can have you can integrate a graphic in the way that you have the path to the graphic, or you can just drag and drop and drop it into the Jupyter Notebook. Just let me show you that in here. So here I've now dragged this CoEC image, and you see it's now an attachment to the Jupyter Notebook. An attachment is really integrated in the notebook itself. If we would open this, it's just with an editor, looking really at the raw text, but I think I did not save it. So let's, well, that's a big one. You can see that these attachments are then integrated in the Jupyter Notebook. What else can I say? Some things you have to use HTML style, and you can directly use HTML in the Markdown. And therefore, for example, here it's aligned to the left, to the center, right, and then changed in size. You can here it's a GIF image you can put in as a drop down, as I already showed you, and as an attachment. So there can be movies in there if you want to have it more colorful. Again, of course, HTML is possible. And here all it's more or less about HTML. I have to speed up a bit. You can go even that far that saying I have a movie in there. So this is not attached, but it's a link. You see here, it's a video control just from HTML integrated in there, or you can integrate you can embed from YouTube videos, or embed HTTP websites. There's a T missing, or even PDFs. So I just hurried up, I think you got a lot of information in the last 2 hours from now. So if there are any questions until now, we can take this time, including the upcoming break, to discuss them. And then we will meet again with going on through the interface at 10:30. So are there?
You mean 11:30?
No. Oh yeah, of course, 11:30. Oh, time is rushing. Yeah, of course, 11:30. So yeah, any questions from your side? And I'm happy to answer them now. Hello again. Here we are, back from the break. I hope you can hear me and see me. And I have my coffee. and can go on with these crash course. I'm not sure if that's the right word in English. Anyway, through JupyterLab. And if you are new to JupyterLab, then you get the recordings, and hopefully you find some time to walk through that again. So we just go on with the same speed, because tomorrow we want to be ready for the HPC systems, and therefore, of course, not be bothered with these kind of standard stuff, which is of high importance, but not that HPC related. So I close this break information. Anything I wanted to say in addition to that? No, I think we can go on with the magics. So just to show you, perhaps one thing I would like to show you again, because that came up in the chat. If you go to the control panel, then we see this is kind of the landing page of Jupyter Hub. And when you choose, instead of choosing Center of Excellence Jupyter, you would just choose the default and start a new JupyterLab, like something like this. Be careful that only the supported characters are the ones above here. Simplify. Now try to use a plus sign. It simply, you do not get any feedback. That's sometimes an issue. So this plus sign stops me from clicking this button. Okay, so I call it 1, 2, 3, 4. And now I can click the button, and now I see all options, at least the ones I have. So, but today we actually want to use the HDF cloud, as there we have dedicated resources for our container. And if you, for example, now go on any other cluster on the login node, then you are not alone on that login node. And JupyterLab, the process, will have to, is treated the same as any other process on the login node. And if we there would go in with I don't know, 50 people in the login nodes, definitely not a good idea. So therefore, better the HDF cloud, to use the HDF cloud. Another benefit from the HDF cloud is that it can run, say, 24/7. So if you start your JupyterLab and you work with it, and you can reopen it the next day and go on at the same, just at the same spot where you have stopped the day before. So even when you close your tabs, you switch your laptop, you go home or you go in the office and open there a different machine, go in Jupyter jc.fz-jülich.de. In the landing page, you can open your JupyterLab, which is still running on the HDF cloud from the day before. We close JupyterLabs, or we close tear down containers when they have not been used for a week. So it is not 24/7, 365 days, but if you are continuously working with it, the HDF cloud is definitely the better place to be. Sometimes supercomputers have maintenance, and also when you start your data analysis on a login node, and it is quite easily, you can quite easily fill up the whole login node with your flooding the memory or using the resources there, then you directly influence all the others on the login node. So this is the HDF cloud is definitely the better place to be for just a quick quick look and perhaps even development of little things and so on. Tomorrow we will go on a compute node. Everyone gets its dedicated compute node, so there you are free to do whatever you like. If you go for instead of the HDF cloud on the Yusuf system, for example, then you see definitely more options and so on. And we thought it's a good idea to add this group up here because this group ensures that you do not get flooded with all kind of options. Like when I go now to Center of Excellence Jupyter, then I simply directly see on Eureka or on Joules or certain settings or options where you can start your JupyterLab are then disabled to ensure no one gets kind of lost in the options. Anyway, we are today on the HDF cloud, system HDF cloud. You see I have two ones open here. Actually, when we wanted to ensure also that you do not by accident start more and more Jupyter labs. Therefore, with these Center of Excellence Jupyter, you're limited to one Jupyter lab. So this kind of makes workshops less complicated. But if you're running then in the standard everyday mode, you will be in the default. And there you have to ensure, okay, where do I want to start my Jupyter lab? Do I want to start it on the HDF cloud in a container? I can run it there for, say, 24/7. And or do I need explicitly really a lot of resources? Then I started on a compute node of the HPC system I have resources for, or do I want to go on the login node because I need to have access to a special storage system, for example. Okay, that said, when you start your Jupyter lab, keep in mind this is just a process running somewhere on our machines. It's nothing else. It's not. It's therefore you have to treat it the same way as you would think of any other program starting. Okay, I closed this one. Okay, now here we are on the HDF cloud in this container on the you can see it on the URL. Well, yeah, these zoom buttons come down. I don't know if you see it, but at least I cannot see the URL anymore. Okay, now and they are gone again. The HDF cloud is in the URL, so yeah, that's this one is running there on the HDF. Okay, then I think we've went through the Markdown stuff. I've seen in the chat, of course, there's much more to tell about Markdown, and ensure you are not limited in your possibilities just by not knowing what is there. Next important thing to talk about are magics. Magics is actually more a thing about about the kernel or the special interpreter running in the kernel than it is about JupyterLab, but it's so closely connected that I think it's important to mention that, because it goes beyond the standard Python or standard R and so on language. So you can have these magics. They are commands for the running kernel. So they are not commands for the JupyterLab user interface. They are commands for the running kernel. And you know, the JupyterLab user interface or the JupyterLab notebook server communicates to the kernel with 0MQ, and so the magics are running in the process of the kernel. And there are two different kinds of magics. There are line magics and cell magics. A line magic means you have a single line command. You can have a special command which just is then the single line, or you have cell commands where you would have two of these signs in front, these characters in front, and then the argument of both the current line and the whole body of the cell is passed to that command. So what can you do with these magics? First of all, they are, as I said, special to the kernel. So there are different magics between the different Jupyter kernels. So here we are in Python 3 kernel, the standard Python 3 kernel. And when you go to R or Ruby or wherever, whatever kernel you need, or Julia, then you can try to list your magics, your different magics. So therefore, I started here with these magic, and you would execute that cell. You can execute it up here with this play button, and as we have seen before, you can execute it with Control Enter, and then we see this output. This output shows all the magics which actually this kernel knows about. There are quite some magics which one can use. It is worth going through them in the documentation page once. I would say there are certain ones which are really helpful, and there are a lot of ones which are too special to worry about. But here I put the link up here to the documentation of all the magics. So as I said, there are line magics and there are cell magics, and also there are quite a few. As this is an output of a JSON output, we have this filter on the side, and yeah, could search that. So that's a feature of this special output cell for JSON. So I would like to point to a few of them which I like to use. This is the time it magic to see how long does it take some command to execute. So if I run this, then this will run this NumPy function and will time the NumPy function. This is quite nice to use. So here we see that it runs this function multiple times, and then tries to find out what is the kind of mean of time it needed, and what are the minimum maximum compared to that. So it does not run it once. It just also nice to know. We have also another important magic is the matplotlib. It has a magic, and this has to be called once in a Jupyter Notebook to use matplotlib afterwards, because matplotlib has certain backends. You probably will most of the time use the inline backend, but as you can see, there are multiple ones. Not all of them are working in this environment, depending always on what is loaded and available. And so the matplotlib inline is the one which is the default to use to use Matplot in your Jupyter Notebook. Another nice thing to know is that if you develop Python code and you have perhaps parallel to your Jupyter Notebook, you have you're working on a Python package, then you want to ensure that whenever you call a function from that package, that it will not be used from the cache, but it will reload. And this is done with these load external, just to ensure that you do not work with your old code and wondering why you do not see the updates, and always have to close the kernel and restart the kernel to see the updates. To avoid that, when you develop Python code, then in a separate Python file, then think of this load extension. This xmood is also some which is nice to know about, because Python tends to flood you with tracing information, and this is this not always helps, and so this xmode can reduce these tracing information, and you can decide how much you want to see, and especially in a Jupyter Notebook where you have this tracing information then all over the place. Perhaps that's also something which is helpful. And nice to know is that you can just run bash codes in your cells, like here. So here we have using the cell magic. So the whole cell is interpreted by this bash magic, which actually then sends the commands to bash and displays the output. It is here important to understand that when you go to a second cell and also use this cell magic, then you will not, it will be run in a separate shell. So I cannot say I do I do an export a equal 10, and then I run that command, and now I could type alt enter to get a new cell, or I could use this plus button up here. And now I do this again and say, okay, great, I have exported A. Let's see what's the result of A. And A is not defined. So in each cell, you have your separate bash. If you want to have, if you want to use the same shell through the whole notebook, then please use this bash kernel. When you're running in a bash kernel, then you do not get for every cell a new shell, but you have one shell for the whole notebook. So that's here the difference to the bash kernel. Yeah, perhaps useful writing a file. Here you see we have written that file. You can open it with the editor. We'll see as expected a file which tells us, which shows us just the line here. Sometimes useful if you want to generate some output. You can also ensure that the standard out and standard error is passed to the running Python kernel. So when we run this, and now we run these check what these variables Arrow and Python have, then you could pass information from your bash cell to your Python code. Okay, so that that's for now at least all about the magics. There's definitely more to say about magics, but I would like to point you to this documentation. Yeah, just keep in mind there are these two kind of magics, and they are depend on the kernel. The kernel actually implements the magics, and they are also then running in the kernel process. They are and yeah, so that's about magics. Then we go to shortcuts. I told you shortcuts. We are used to terminals, and therefore we like to do a lot of things just keeping our hands on the keyboard. And shortcuts are just for that. JupyterLab is designed from the basis on to be used from the keyboard, and therefore one wants to tune it and modify it. So just some general information about shortcuts. Shortcuts, if you go in the menu, for example, here, you see that some of the menu items have shortcuts listed here: Control plus, Shift plus, closing bracket, and some of the menus items have then one with a comma, I. So the difference is, but I think this is standard. The ones with plus, you have to keep all the keyboards pressed at the same time, and the one with commas, you press one and then the other one. Every key is capital because the keyboard shortcuts are always listed the way as they are shown on your keyboard. But this is not Jupyter specific, I think. Important, I already said that, important is there's the command mode and the edit mode. With escape, you enter the command mode, and with enter, you enter the edit mode. So now we have the cell active. When I press enter, I'm here, down here, you see I'm in the edit mode. And I press escape, I'm out of the edit mode, I'm in the command mode, even though I have not executed this cell. So I press enter, control enter, and I've executed it. I think we already went through this. Control enter gives you, executes the cell, shift enter executes it and moves to the next one, and alt enter executes and creates a new one. So next one, let's make it say more special. If you want to, we can enter a cell and let's say run it first. See, that's the output. And now we enter the cell with enter, and just so you can see everything. And no, anyway, okay, the screen is too small. So we can enter here, and if we want to split it, for example, Control Shift and minus will split the cell into two. And if I want to merge it, I Oops. Oh, no. What am I doing? This is now what happens if my Firefox thinks it has to grab some keys. What's going on here? Yeah, that's perhaps sometimes a little bit of a pain, I have to admit. Perhaps I have to, I'm using Firefox here, perhaps that's less complicated with other browsers, I don't know. But some key combinations are then grabbed by Firefox, and one has to get a bit aware of that. So, okay. I can select these two cells, press Shift M, and have merged them again. Undo, have to ensure I'm in a command mode, so that's for escape, and with Z I'm back in I'm undoing whatever I did before. Okay, so here I think this is good to know. So you can with B create a cell below, and with A just go A, create a cell above. Can delete the cells with double D. Undo, we already had undo. I can say Shift Z. Okay. That's strange.
You need to do Z before for the undo, and then you can undo the undo with Shift Z.
Okay. Okay. That makes sense. Okay, so we can just create a cell below here, enter the cell with enter, type something, and then Control or Shift Enter to execute it. If you want to use Markdown, you create type M here above. You see it's Markdown now. Or with Y, you are going to code again. So let's execute that. Of course, you can copy a cell and pass it somewhere. Here with C and V, so not a Control C, but C alone. And very important to know is Control S for saving the file. Control F for finding something in the file. Now it's listed here. You see there are there's 4 times the 100 in there. You can replace it. I think that's also kind of used a lot. Here we have now replaced it with 200. We can restart the kernel. Here you see the kernel restart is 00. It will ask if you really want to restart the kernel. This does not mean that the output is gone, the output generated before. So Now we are coming to customizing the keyboard shortcuts. So you might want to, at least it's for me the case, you might want to have something like restart the kernel and clear the output. And this is here, restart kernel and clear all outputs, but there's no keyboard shortcut for that. But every command can be, a keyboard shortcut can be given to any command. So just let us add these keyboard shortcut for restarting the kernel and clear all output. So I go to Advanced Settings Editor and we'll close this file browser here, so we have more space. And there we have the keyboard shortcuts. And keyboard shortcuts is, again, as I said, it's a JSON file. All settings are JSON files which you can override or extend with your user preferences. So the system defaults are always read and interpreted, and then the user preferences are coming below. Here we see we have no user preferences, so we just have the system defaults. Because there are so many commands and it's quite difficult to find, they have listed all of them here. And so we can search for restart. And here we already see kernel menu, restart and clear. So this is actually the one we want. And if you go to restart and clear, if you go to the next, you can press Ctrl-G for jumping to the next found place of this restart and clear. So with Ctrl-G, I jumped into the right spot here, and I can say, okay, I just copy this section. I see there's no keyboard shortcut for this. And I just copy this one. Just one thing to mention, if I right click here, here it works. Okay. Sometimes you have to press, at least on Firefox, Shift to ensure you get the copy, this standard menu. So we can put it up here, but this will not work, and it will send command not valid property. Why? Because you have to build the same JSON file as it's on the system defaults. In the system defaults, and this JSON, it starts with this bracket and also just this one. And then we have to close this and this. What's wrong? Okay, now it's fine. So we are overwriting this, and we want to have, of course, some keyboard shortcut which does not conflict with any other shortcut. So I just say, we type first an R and then we type an I. Don't ask me why. I just say, okay, with an R and I, it shall restart the kernel and clear all output. I see there are no errors found, and I can save that. And from that on, I have these R and I in here. So this is yeah, that's the way you create your own keyboard shortcuts, which is possible for all commands which you find here in the command palette. So now if we say restart, oh, I was expecting that we can see the shortcut actually. Okay, anyway, we see it in the menu that it has worked. So we can close this settings editor again, and let's see where we have some output. We have here this output, so hopefully we can say R and I tells us restart, and as you can see, it also cleaned the output. So this just to let you know how to create your customize your keyboard shortcuts. But I've written down here some more instructions on that. I really think it's very, very helpful. If you now want to know, okay, where is all these settings are stored? Okay, just see that questions. No, it's not case sensitive. So a keyboard shortcut is always the keyboard, the character printed on the keyboard, and if you type a capital or a lower R, it makes no difference. So where do we see these kind of settings now stored? We have these in your home directory. You have these .jupyter directory, and in there, actually all your settings are stored, your personal settings. And there we have these lab directory and user settings, and then we have these shortcut extensions. Here use these exclamation mark, so that is directly a command to the bash, and you can see that whatever we have changed in the advanced settings manager is now in these shortcuts JupyterLab settings file. Yeah, there are definitely more about shortcuts. I've listed the ones I think which one should know, but you have to decide by yourself which of them are for you important and which of them do not have no relevance for you. So with that said, we are done with the shortcuts. So I'll close this. You see here, this file is not saved, but I think I already said that. So when you try to close a file which is not saved, of course, it will ask you if you want to save it, but we do not want to save this one and this one also. And the magics, we're done with the magics. So let's talk about the workspace. When you start a JupyterLab, then this JupyterLab will can serve multiple workspaces. So for example, you have 3 monitors and you want to have your one Jupyter Notebook server showing up on all 3 monitors. Then you can, of course, try to arrange them the way that you just increase your browser window, or you can just restart or just create multiple JupyterLabs connected to the same Jupyter Notebook server. So in your browser, you have multiple JupyterLabs running, but they all connect to the same Jupyter Notebook server. And this is actually quite easy to do. You just copy your URL, and then automatically the Jupyter Notebook server will see and that there's a second one browser tab connecting to the same Jupyter Notebook server. And as the Jupyter Notebook server cannot work in the same workspace, had to save somewhere where the tabs are and what is open and so on. For these two different browser tabs, it clones the workspace just in that moment. So here it was quite fast. So I just would like to point you see that when you call that the same URL, you will see there comes a clone, starts a clone function, and then you will see that the URL will change, and the workspace, which is before the name of the JupyterLab you have given in the landing page of Jupyter Hub when you started it, is now some automatic generated name. So here the clone of this is called now auto -r. So it just automatically generates another one. To show you that this is the same Jupyter Notebook server running, we can go here on the running terminal and kernels. We see we have all these kernels running connected to our Jupyter Notebook server. So when we go to the clone, so in the second tab, I can open there the running terminals. I see here I also have the same kernels running. So this is just a copy in the browser, so on the client side and not the Jupyter Notebook server. Sometimes this is helpful to have multiple JupyterLab tabs running on different monitors, but connecting to the same Jupyter Notebook server. So, but for me, at least now, it makes no much sense. So I close this again. Would like to show you these workspaces. Whenever you start such a new JupyterLab, then a workspace is created, or not, it's saved at a special place, and here these workspace configurations are then saved to Jupyter Lab and then in the directory workspace. And you see I have a lot of different workspaces here, and you also see the one which was cloned and was called auto R. It is good to know that when you arrange your tabs and all the things here, and you just close your Jupyter Lab, even on the server side, and you restarted it from the Jupyter Hub landing page, restart with these buttons, start, and you have closed it, stopped it, and you started again. Then it will read from these directory lab workspaces. It will read the files and will rearrange your workspace the way you have left it, and you want to have it. Yeah, also nice to know. And of course, this workspace is a JSON file. Let me just I'm not sure if let me just put this here. And run that. You see what's in there. It's just how everything is arranged. So so you know now this home.jupyter directory gets all your personal settings and also the workspace. Of course, as it's a JSON file, you can show it as a JSON file. I thought at least it's okay. I did not. Oh, sorry. This is an old. Well, this was an old example. That file does not exist anymore, so we take the one we just generated this auto -r clone, and there we see yeah, the JSON file with all the kind of information in here. Okay, so now you also know all about the workspaces. And now just have a look at other kernels. I close these again. Now I do not want to save and like to talk about other kernels. When I say other kernels here, I mean other kernels which are coming from other kernels in thinking about the computing languages, the programming languages. We will see how to generate our own kernels and so on tomorrow, but just the one which are installed. So Jupyter has certain path where it looks for kernels. And this command, Jupyter --path, this will show you all these paths. Just let me make it a little bit larger here. So this will show you all the paths. We have config path, data, and runtime path. And when we are thinking of the kernels, then they have to be in the data path. These are the paths which are searched for kernels. And here we see that at least in our system, this is the same on all our systems, independent of HDF Cloud, of Eureka, Jules, Yusuf, Deep, HDFML. So all these clusters, they all are structured the same as we install our software with a tool called EasyBuild, and each kernel which is supported here is a separate module, and therefore loading that that module would end up in showing these kernel in the launcher. So when you go to the launcher, you see we have these kernels up here: Python, Bash, JavaScript, Julia, Octave, PyDeep Learning, and Ruby, at least on the HDF Cloud. And these are the ones which you find here in the path of the data path of Jupyter. I want to say here. This what we can see here, the data, the path where it's searched is actually environment variable called Jupyter path, and there in this environment variable, there we will find all these paths. And if we look at one of these paths, how it looks like here in the example for Jupyter Kernel Ruby, we see it. It has these special files. Actually, the kernel JSON file is the most important one. There, all the information are stored, which Jupyter reads to know how to start this kernel, how to use this kernel. And if we now have a look at a few of them, Julia, for example, here this great Julia program. You can see up here that Julia 161 is loaded as a kernel. Currently, we see that the kernel is connecting. So when you start up a Jupyter Notebook, then the kernel will start up automatically. So you cannot open a Jupyter Notebook, which has a certain kernel mentioned in the meta information of this notebook, and avoid that it starts this kernel. At least to my knowledge, this is not possible. So here we have this Julia IPyNB Jupyter Notebook. We have double-clicked on that, and it opens this Julia Notebook. And if we look at the properties in the advanced section, we see that it knows about this kernel, Julia, language Julia, and that it's looking for this kernel like that. And then it will start up that kernel. Of course, afterwards, you can always click on that and you can say no kernel or change that kernel. And then in the beginning, this circle is filled. And when it's connected, it started up. That can mean it loads a lot of modules. It needs to execute this kind of communication part which connects to the Jupyter Notebook server. And when it's connected, then you will see that the circle is white and the kernel is idle. So it's ready to run. And then if we run it, you see that it becomes black again or filled again, and it's doing something. Because now this is kind of a lot of plotting, it will load quite a bunch of libraries, and in the beginning it takes some time, at least here in this example, because in the background it needs some stuff to which was not loaded just because the kernel started. Now really Julia starts. You can see in the memory that it goes up and prepares. And of course, the second time you run that, this is of course not that, does not take that long anymore because everything is loaded, but this is how we would expect it. You can also see that in the beginning we had one here. This was the first bunch of the first command to the kernel, and every time we run it again, and of course this goes up. Yeah, you can of course also connect here the console to that notebook, and the same as with Python, for example, copy cell to the console and run it here. So that's the same as I've shown you before. We go now to the running kernels. We see we have 1.13 gigabyte memory used, and now we shut down the Julia. It will release that memory, and actually you can shut down all the others too. And you see we are down again to 142 megabytes, which is needed by the Jupyter Notebook server itself. Okay, so there are others like Octave. And again, here we see it's connecting. Some kernels are starting really, say, a big environment in the background. So it can take some time. Some are quite small and fast, like Bash, for example. And if we start now here drawing our nice heart, we have our Octave. We do not have an R kernel in here. I'm about to make sure we have everywhere the same kernels. Until now, we have not included the ones which are using MPI by default on the HDF cloud. This will change, but that's why it's currently here a limit. So when you open R, for example, then of course that's wrong. It tries to use Julia, probably because I was playing around with it last time, but it actually should not use any kernel, because it of course cannot. Julia cannot run these R commands. Okay, so that's at least all about the different standard kernels and how they interact with the environment. And next, okay, so we are done with first steps. I think we're done with first steps. Yes, we're done with first steps. So I can go to the extensions. So let's open some slides. And we all know about the live document. We all know about the repository. Just some important things, I think, which one should know. Secret number one, tell us if something is not working the way you would expect it to work. And there are too many features, and I hope you can imagine there are too many features to be aware of all of them. And we, of course, really would like to optimize it in a way that it's best for the community. And yeah, and of course, also here in the Center of Excellence, we think this is a great tool, which is good to be, yeah, which gives all possibilities to tune it to certain use cases. So just let us know. Then the second secret is, if for whatever reason your laptop gets disconnected from the internet, or whatever reason your browser in the end gets disconnected to the Jupyter Notebook server, then you will see this dialog, server not running. Server not running just means from the point of view of the JupyterLab running in your browser, it cannot see the server anymore. Perhaps in my case, the Wi-Fi is down, or I don't know what. Don't be afraid about that. Server not running just means you need to reconnect. Perhaps you have a slow connection in this moment. Hit dismiss, and it will just say, okay, I try again to connect, and we keep on working as soon as I have a connection back to the Jupyter Notebook server. You also can hit restart. If you hit restart, then the whole JavaScript part running in your browser will be re-executed, will run from the beginning. This will end up in the same result, but it restarts everything in the tab. So I never hit restart because I know I have sometimes, especially when my children are in the internet, I sometimes get issues and see this dialog. Same as for if I want to save something, and in that moment your connection to the Jupyter Notebook server got lost. That just does not mean your file is gone. Everything of this happens on the Jupyter Notebook server side anyway. So it just means that in this moment, there's, for whatever reason, no connection to the Jupyter Notebook server. In the worst case, you always know I can go to the landing page of Jupyter JSC, hit the open button, the green one, and we'll see the Jupyter Notebook server, which is still running on the system. So everything is safe there. Okay, let's talk about the extensions. I already said the extensions are everywhere. JupyterLab is a bunch of extensions. One extension builds on another extension, so it's not only a bunch of extensions, it's a tree of extensions. Even I want to emphasize on that, even the basic extensions like a file browser is just an extension as all other extensions are. So you could even think of replacing this file browser with your own file browser. There's no say privileged extensions. I don't think it makes much sense to replace the file browser, but at least you know you could do it. If we want to know which extensions are installed, then we can type in JupyterLab extension list. Let's do that in a terminal. So we open the launcher, open the terminal, and say JupyterLab extension list. So now it goes down through all installed extensions which are currently enabled. You see, we have added a few of them. This spell checker, for example, is the one down here, which shows you when you are typing at least the English grammar there. They are extensions which you do not really see, which are active when you do, for example, bouquet, which is visualization library, or Git. We have seen Git, which is here, which is quite well visible. Yeah, I will really show you a few of them, but you see there are quite some extensions which makes life easier, hopefully, and are useful for a broader community, or for everyone a little bit. So just going back to okay, I can use these open tab panel. So you've seen this is the way to list all the extensions. Extensions are installed in the JupyterLab dir. So there's where all the extensions are, and these standard JupyterLab dir points to a system directory. So in JupyterLab 2, which is currently the one we are running here, you remember that's the one you have chosen in the landing page of Jupyter, of the Jupyter Hub, Jupyter JC. When you decided to go for the HDF cloud, you decided for a certain image, and there we had selected 2022.6. So in this 2, at least for us, it means we are running JupyterLab 2 in here, but of course we can also check in help and see we are running here version 2.2.9. And in this version 2, the extensions are added to JupyterLab at build time. So when JupyterLab is generated, then all extensions are with all extensions, it creates one build, and therefore you can have only the option as a user to add new extensions by rebuilding the whole JupyterLab. This is gone with JupyterLab 3. We will switch to JupyterLab 3. I think quite soon it at least will be an option. There you can have extensions, just adding these extensions by adding a certain configuration information and extensions are not part of the build, at least not necessarily part of the build. Okay, just to let you know, these extensions in JupyterLab 2, they are part of Jupyter, the whole Jupyter build, so they cannot be changed that easy. It needs a rewrite, a rebuild. Okay, what extensions are there? I will show you a few in live in a notebook, but I would like to point you to more of them. Just showing you some slides, and you decide if it makes sense to dig in deeper. So IPy there's not sorted at all, to be honest. IPy volume will allow you to do 3D plotting from Python using WebGL, and therefore is quite fast when showing 3D visualization in your Jupyter Notebook. It will run, though, it will download the, thinking of WebGL, it will get the whole data set in the browser and will render it there. So this is only of use if your data set is that small that you can load it completely in the browser. JupyterLab Git, we have seen that. I think this is really a very, very useful one, and I'm using it a lot. And in my standard day life, I'm using JupyterLab Git. We have these JupyterLab LMod, which is just one here, which shows you which modules are currently loaded. If you're familiar with HPC systems, you know that too often, at least on most of the HPC systems or sites, you decide which software you want to use by loading a certain module that will modify your environment you're running in, and therefore you have these software available. And with these extensions, you can unload or load modules which are available on our system. Be aware that this comes with a little kind of a risk. If you unload something Jupyter needs, then this can destroy your environment. So if I would now click on unload Jupyter, then of course I cannot expect that my Jupyter still works. So you really change the environment variable of the environment where the Jupyter Notebook server runs in. And when you then start a new kernel, depending on if the kernel will use the environment settings from its parent, from the Jupyter Notebook server or not. Depending on that, these modules will then be available in your kernel. So it is useful, this extension, but one has to understand what's actually happening in the background when you, for example, click on unload. It is better to build your own kernel, but we're coming to that tomorrow, building your own kernel. So this is more kind of a quick and easy way to add some little things, but it's better to build your own kernel. Okay, we have this table of content in here, useful if you want to have a big markdown or a big Jupyter Notebook and you want to just jump between the headlines. And we have the Py3.js. 3.js is a big 3D library, and therefore Py3.js just allows you to use that in a notebook. PyLeaflet brings maps to Jupyter, interactive maps, quite famous for that. of course, matplotlib, that's really one of the default extensions, I would say. And bdime is nice to see differences between your Jupyter Notebook, which you have opened, and the one, for example, in your Git repository. Let me show you that. If we just go back to something, we have some Jupyter Notebook where we have changed something, and then we can we can see at the top we have these Git button, and we can see, okay, that was not much. There was no change at all. Going there. Okay. I was surprised. I don't see any change because I see last modified 2 hours ago. So yeah, this will show you changes in compared to your Git repository, or you can also let me just go out of the single document mode. You can also, I just close that again. Okay, now I'm really lost with all these tabs. This one. You can also go on these and see the difference to the checkpoint file. You remember the checkpoint file is stored when you explicitly say save, and autosave will save every 120 seconds, and this will show you the difference between your checkpoint file and your current saved file. Okay, so just talking about these 120 seconds, of course, you can change these 120 seconds in the advanced settings editor. So just show you that if you go on the document manager, you will see that we have here a 120 seconds autosave interval. So just good to know that. But I'm close this one and go back to the slides. Plotly is also something similar to matplotlib, but allows you to bring your plots into the web. There's a service behind that which is kind of nice and therefore definitely useful to know. You create your plots and then you say, okay, just put them on the web, and they are interactively behind a URL you can pass to someone else to make it even easier for a group of users to look at your results. Sidebar, we'll have a look at that in a second. Quick open, yeah, it allows you more quickly to open a special file, can be of use. But Voila is more nice to know. Voila allows you to make a dashboard from your Jupyter notebook. One could take a whole workshop just on Voila. How do I create dashboards? There's actually a workshop in June on that, which allows me to have to use Jupyter or notebooks, creating my dashboards, and then bring them into the internet just by Voila. Voila has the advantage that in the background, really a Jupyter Notebook server is running, so you can display much bigger data sets than you would be able to do if you have a web app, generate a web app, which is then running on a dedicated VM or so. If you want to have access to your terabytes of data with with the dashboard, then voila is probably the better choice. So that's why we look into voila. Okay, so we have seen this LMOD Dask lab extensions. We will look at that tomorrow. That's how to schedule my make use of parallel execution from inside my Jupyter Notebook into a kind of to a scheduler which is limited to my resources I have on a supercomputer in that moment. We also will look at server proxy tomorrow. How can I avoid tunneling? How can I ensure that I can have how can I access web apps like TensorBoard or something ParaView PV server without the need to do any tunneling, but just using the tunnel which is actually already there set up by the Jupyter Hub and your Jupyter Notebook server. So that's really nice. So you can right away get through all the kind of firewalls and limitations to the compute nodes and share web apps or data with your browser. Okay, so that's all from these slides. Just quickly go through a few examples and close all these tabs again. Down. Okay, we've closed that one. As you know, of course, in the background, they are still running. Can also, I want to close all. I can just use that one. Okay, there's not much to close. I just see a question about LaTeX documents. Yes, there is a LaTeX extension, and I think it's no, not I think I know it's installed here. So you are able to open LaTeX documents. I have right in this moment I have no example here, but would ask you to try it and let me know if there are any issues on that. I'm actually waiting for this LaTeX extension to be ported to JupyterLab 3. That's one of the extensions which are missing to do the next step. And so yes, definitely, it's I think in our environment LaTeX is of more than of help. Okay, so extensions. Just go through a few of them. I said sidecar extensions, sidecar extension. Just show you that when you run this this code, we see we get these extra on the side, so we can put it to the side. That's similar to our no, not here, to these extra output view one gets when you right click on output cell and then say give me this output an extra view. We can put anything in there. Here now we use the IPy leaflet. IPy leaflet, it shows you maps, nice map of Jülich Forschungszentrum, if we go in deeper, close enough, we might even see the supercomputers, but not today. So so we can have this output in here. We can, of course, as I said, we can, of course, right click and say create new view for output and have it in here. But instead of doing that, we can also send this output to the sidebar, and then you would have it in here. So you can have your outputs tabbed with this sidecar. I think we talked about this lab extension list, and here you see this is the LaTeX extension installed. I've shown you JupyterLab LMOD. I've shown you the difference in NBDime. It's really a pity that I could not show you the language server. I have no idea what was going wrong with that. To check that, I think it's very, very useful. Just at the second place, just behind Git, at least for me. And here, I just want to show you that these system extensions, they are these lab extensions, they are system extensions. So if you try to disable, for example, this extension, then Jupyter tries to do a change on the system part. And of course, this will end up with an error because it's a read-only file. So the extensions with JupyterLab 2 are as they are, as long as you do not install Jupyter in your home directory. And I will come to that tomorrow. You are free, you're not forced to use the installation of Jupyter on our systems. You can come up completely with your own Jupyter installation, and Jupyter JC will respect that and will open your Jupyter from installation in your home directory or wherever you do it. So don't be afraid you're forced to use this kind of installation. Okay, I close this sidecar again, and just in the last minutes, go through some nice extensions concerning visualization. We have these Py3 3JS, and we can visualize here. Okay, that's really boring visualization, but I just wanted to tell you, to show you that of course you can, not of course, but you can even manipulate that. And this is really just the smallest example one can think of for Py3JS. Then looking at more complicated one here, of course, these visualizations there's no problem having interactive visualizations in a Jupyter Notebook, and interact with it in a way that users can, for example, click on something, you can grab the output, and this is not, the output is not static. Okay, that's the main point I want to make here. Then making it a little bit more, say, more advanced, like you can have these kind of interactive widgets. It's with the whole IPy widget ecosystem, you can design your whole widgets, and therefore make, for example, for dashboards or anything where you really want to interact with your data. It's of much use, especially when you give it to other colleagues or other people, and they do not want to program. They want to just analyze or just explore the results. This is of course of great use. Okay, and here this is no combustion. So I'm here, a very simple example for Plotly, but I think that's too boring. I just show you the ITK widgets. Here we first need to download an engine or file showing scan of an engine, and there you can see that you can integrate really big frameworks into Jupyter notebooks, and ITK is also a framework which is here installed and ready to be used. So one can imagine that this is far beyond just, say, programming a bit, but really doing visualization, useful visualizations in this way, a 3D visualization. Okay, I really made it. Great. So I have 2 minutes left, and I hopefully I have not lost all of you, but I really was. I was hoping to rush through the whole JupyterLab and give you all information you need to work with this environment in just what is it, 3.5 hours. Now I think we are ready for jumping to the HPC system tomorrow, and I'm happy to help you with any questions which came up in this morning, and take the time, go through these notebooks, and just try to reproduce what I've shown you in the last hours. This was, of course, I'm aware that this is more presentation or live presentation, and we add the kind of interaction in the afternoon if it's needed. But we are so close in time, though short in time, that I think it's best for all to rush through it, and then we will add the recordings of today to the live documents, so you can will find a link to the recordings of this workshop of the last 4 hours, and of course there you are hopefully then also can walk through that. And with these said, I would say we are done, and you can stay on the HDF cloud and play around as long as you like. This project, this training project, these resources which you are part of through Jupyter, through UDOR. I said Jupyter too much this morning. They will stay here until the end of the month, but I think tomorrow we will use quite of them, and I'm looking forward to see you then. So stay healthy and stay in this room if you have questions. Bye-bye and see you.